Welcome to Ocean Acidification Week 2023, and thank you for joining us today. This is day 4, and you're here for the Northeast Atlantic Hub session. My name is Katarina Shaw. I'm with the Intergovernmental Oceanographic Commission of UNESCO, and I would like to just do a quick introduction of Ocean Acidification Week. So OA Week is organized by GOA-ON, the Global Ocean Acidification Observing Network, and sponsored by NOAA, the United States National Oceanic and Atmospheric Administration, by the IAEA OAICC, which is the International Atomic Energy Agency Ocean Acidification International Coordination Center, and by the IOC UNESCO, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization. So GOA-ON was established in 2012 with just a handful of members. Since then, we've grown tremendously and now have over 1,000 members from around 114 countries. We also have 9 regional hubs, and we'll be hearing from most of them during this week, like the Northeast Atlantic Hub, which you can see on the top of your screen there in the middle, which we'll be hearing from just now. If you're not a member of GOA-ON yet, you can join by going to goaon.org and signing up as a member. So OA Week debuted in 2020 and returned in 2021 when events and conferences were postponed due to COVID-19. Following the successful in-person meeting at the High CO2 Symposium in 2002, we're bringing back OA Week for 2023 to maintain momentum around OA research and to provide a virtual platform for the ocean acidification community to exchange their latest findings. We're thrilled to be able to present a range of ocean acidification topics and speakers from around the world. During the presentation, all participants are in listen-only mode. This presentation is being recorded. You're welcome to type any questions into the question box. This is the Q&A box that you see at the bottom control panel on your screen. We'll be monitoring the incoming questions and we'll pose them to the speakers during the question and answer session after all the presentation. You can also use the raise your hand function, and we will then call on you and unmute you so you can talk and ask your question directly. With that, I would like to hand over to Helen Findlay, our moderator for today. Helen is with the Plymouth Marine Laboratory in the United Kingdom, and she is also the lead of the Northeast Atlantic Hub. Helen, the floor is yours.
Thank you, Katarina, and thank you to the organisers for hosting our session today. Our session is aimed at using work around the region, especially with the latest update from OSPAR and also HELCOM, to discuss linkages between science and policy, discuss improvements for future regional assessments, discuss good data coverage, including getting an update on the development of regional CRMs, and we aim to inspire the Northeast Atlantic Hub community to coordinate monitoring and data efforts, but also to inspire other regional hubs to conduct monitoring in a policy context. So without further ado, I'd like to introduce our first speaker. Our first speaker today is Jos Schilder. Jos has a background in freshwater paleoecology and climate sciences, having done research on lake food web dynamics, stable isotope ecology, and lacustrine greenhouse gas dynamics. He currently holds a position as Senior Advisor with the Dutch Directorate General for Public Works and Water Management, Rijkswaterstaat in the Netherlands. In this capacity, he is tasked with bridging the gap between policymakers and the scientific community, and he is a delegate to the OSPAR Convention bodies concerned with biodiversity, climate change and ocean acidification, and the EU Marine Strategy Framework Directive Working Group on Global Good Environmental Status. He is also a Dutch national representative on the Science Committee for ICES, and he will be talking to us today about the recent OSPAR assessment. So Jos, I'll pass over to you. Thank you.
Thank you very much, Helen. I was not aware that you would read that aloud, otherwise I would have never let you say Rijkswaterstaat. I wouldn't have put you through that. Try to share my screen. Is everyone seeing my
Katrina, do you
screen?
have to? Oh yeah, it's coming. Yep, it's
there?
good.
Good, thank you. Yeah, so thank you very much for the introductions. So my name is Jos Schilder, and I'm indeed an employee of the Dutch government, and I've been co-chairing the OSPAR group on ocean acidification. And this group is nowadays merged with the climate change expert group of OSPAR. And so it's called the Working Group on a Changing Ocean Climate and Ocean Acidification right now, or the Working Group COCO. So the ocean acidification assessment I will be presenting on today was published earlier this year, but it is a substantial report, and I don't have the time to do all the work justice in this talk, so I won't be going into the scientific detail too much, but I will be highlighting the main outcomes and recommendations for future research and policy that came in the report. Just a little background about OSPAR. So OSPAR is the Regional Sea Convention for the Northeast Atlantic. In OSPAR, 15 governments and the EU work together towards the OSPAR vision of a clean, healthy, and biologically diverse Northeast Atlantic Ocean, which is productive, used sustainably, and nowadays also resilient to climate change and ocean acidification. So that's really, let's say, a new focal point in the OSPAR strategy. The history of OSPAR actually goes back to the 70s when the Oslo and the Paris Conventions against pollution of the sea were adopted. And in the 90s, they were merged to form OSPAR. And later on in the 90s, also biodiversity became a topic in OSPAR. I think the interesting thing about OSPAR is that OSPAR is a platform where scientists, policy advisors, and policymakers interact quite intensively. So it's in that sense, not unique, but quite special place for the science policy interface. And one important thing that OSPAR does, it produces quality status reports. So we've produced 3 now in 2000, 2010, and 2023. And in these quality status reports, we assess the status of the marine environment, we inform policy, and we evaluate measures. And for EU member states, quite importantly, it's a basis of information for the Marine Strategy Framework Directive reporting. And the latest quality status report included 130 assessments, one of which was the ocean acidification assessment. Now this slide is just to show that we have worked with 30 people for 4 years to produce the ocean acidification assessment. We worked closely together with the GOA-ON Northeast Atlantic Hub. Some of the members were also part of the ICG on ocean acidification, and also with the Copernicus Marine Service. The assessment has 4 main chapters. So one on past trends and variability, one on future projections, one on ecosystem impacts, and one on adaptation and mitigation. This is just a slide to show the 30 people that worked on the assessment, as well as their affiliations, and you can see that it has a good geographical range in the group. So it spans from Iceland to Portugal, and from Ireland to Switzerland, and anything that's in between, basically. So we're quite happy to have such a broad group of experts together. So the first chapter on past time series and variability contains 4 types of basically analysis. So we have in situ time series, we have reconstruction synthesis products, we've used model hindcasts, and we've made a synthesis of open ocean deep water database information. On the map here on the left in the bottom, you see the in situ stations that we've been using. Most of these stations are coastal, and on the right hand side you see an example of some of the plots we produced based on these in situ stations. These are the 4 most northern stations. They show trends and seasonal variability, with in the black dots the deseasonalized data, in white dots let's say the base data points, And in red, if there was a significant trend, you see that reflected in the red line. In addition, we used these synthesis products produced by the ETH Zurich and CMEM, so ETH on the left, to investigate trends in pH and aragonite saturation on larger geographical scales and let's say a different resolution. Of course, these products are somewhat weaker in more shelf and coastal situations. So we also used hidecasts of regional process-based models to look at let's say at the shelf areas with a bit more wide geographical scope compared to the in situ measurements. So for the future projections, we've been using two regional process-based models, which were driven by the high and the mid emission scenarios up until 2050, and also up until 2100 for the high emission scenario. These models cover most of the OSPAR area. So we have the Arctic waters on the left and the shelf areas more to the south of the Arctic on the right. And we also produced model outputs for aragonite saturation and also of these parameters in the bottom waters. With regards to the impacts on ecosystems and ecosystem services, we enter into a more complicated study area, at least in my opinion, because we deal with many interactions and co-occurring pressures, and the evidence base is relatively thin, with all due respect. But for example, much of the evidence is based on experimental work, work in small geographical scales or aimed at a very specific organisms. So we therefore used case studies on cold water corals, Atlantic cod, and bivalves to paint a picture to the policymakers of the problem, and we reviewed some literature on economical impacts. And what is shown here in the pictures comes from the cold water coral case studies, where on the left you see the spatial distribution of cold water corals in the OSPAR area. And on the right-hand side, model outputs of the future depth of the aragonite saturation horizon, which of course, if it moves up to too shallow depths, it can threaten the habitats these cold water corals form. To provide policymakers in OSPAR with an action perspective, we also wrote a chapter on adaptation and mitigation, with this as, let's say, a central figure. And it's maybe, if you're not into the whole OSPAR ecosystem, it's maybe a bit hard to interpret, but it plots the elements of the so-called Northeast Atlantic Environment Strategy. And that's a strategy in which OSPAR defines its strategic objectives and ambitions for the coming decade up to 2030. And these strategic objectives are can be found in these numbers S1 to 12. The objectives themselves are not shown here, but this is just for the policymakers to know where to refer to. And these objectives are related to the, let's say, to the OSPAR vision I mentioned earlier of clean seas, healthy seas, sustainably used seas, and diverse seas. And the actions, in addition to the, let's say, the strategic objectives that OSPAR has put for themselves, we also plotted here actions that are within the remit of OSPAR that might help to alleviate or lessen the impact of ocean acidification. So we see, for example, in the top under clean seas, pollution reduction, preventing habitat loss, disturbance to protect and conserve habitats and ecosystems, restoration of habitats, monitoring and assessing the situation, of course, and of course, looking into the risks and options of subseabed carbon capture and other ways to store carbon in the ocean. And I guess this plotting just the stuff that's in the remit of OSPAR is quite important because, for example, the most obvious one, which would be stop loading the atmosphere with CO2, is something that OSPAR is not competent to achieve, right? It's not the forum where the
There seems to be a slight technical. Oh, you're back. Jos, can you hear us?
Yeah.
Okay, you were frozen there for a second, and we missed the last bit of your presentation, I think.
Where did you lose me?
We lost you, I think, on the second to last slide.
This one?
I can't see your slides at the moment, I'm sorry. Can you share your screen again, please?
Yeah. Sorry about this.
No.
Are you seeing my screen now?
Yes, thank you. If you could take it from there.
Yeah.
Thank you.
Okay. Well, I'll just take this from the start then, because I don't know, and any apologies for any overlap of what I already said and you already heard. But the final chapter that we wrote was to provide policymakers in OSPAR with an action perspective, which is a chapter on adaptation and mitigation. And this was the central figure. And in this figure, we've plotted the elements of the Northeast Atlantic Environment Strategy, which is the strategy that OSPAR has written to define its strategic objectives and ambitions until 2030. And these strategic objectives are shown here as numbers S1 to S12, which are, I mean, the objectives themselves you don't see here, but this is just for reference for the policymakers. And we've plotted these objectives against actions that are in the remit of OSPAR that are relevant for ocean acidification. So, for example, we're talking about pollution reduction, preventing habitat loss and disturbance, conserving habitats, restoring habitats, but also looking into the risks and potential of carbon capture and storage and blue carbon and other nature-based solutions. And it's important that we communicate to the policymakers about actions that are in the remit of OSPAR, because the most obvious thing would be to stop loading the atmosphere with CO2, but that is something that OSPAR is not competent to achieve, though we can, of course, communicate and make those in control aware. The key messages of the report were that ocean acidification is observed in all regions of the OSPAR maritime area. However, the rate of change varies per region, and the local processes have a strong influence on the speed of change. Ocean acidification is projected to continue under the studied emission scenarios, and we've even seen an acceleration of ocean acidification for the high emission scenario. And the seafloor area of deep waters corrosive to calcareous structures is projected to increase significantly. Ocean acidification puts marine life further under pressure. And in this chapter, we've also seen that ocean acidification pressure typically coincides with other pressures. So there's a multi-stressor situation that's not just climate-related pressures, but all kinds of pollution and exploitation pressures. Threatened and or declining species and habitats are particularly vulnerable to ocean acidification, and there's significant economical consequences expected due to ocean acidification. And another thing we've considered is that ocean acidification needs to be taken into account when considering climate change adaptation and mitigation. Such measures may alleviate or exacerbate ocean acidification and its impact. And removing other pressures from the system can increase ecosystem resilience to ocean acidification impacts. Our recommendations for research were that we recommend OSPAR to keep on supporting the monitoring of ocean acidification, and then pay special attention to all the components of the carbonate system, so not just pH, to monitor at appropriate spatial and temporal resolution, especially in the coastal areas, to optimize the monitoring for biological impacts, and to optimize the monitoring for informing and also evaluating measures. We recommend to support work on using model ensembles. So we've used 2 regional models, but of course, if you use more models, let's say the uncertainty around your projections reduces, so you get better products. Especially on the biological impact, there's a lot of work that still needs to be done, and we've advised to consider realistic and not just worst case scenarios in the studies that are being done, and also to try to take into account the modulating role of multiple ocean stressors, to look at ecological interactions and also at evolutionary processes, especially for organisms that have short generation times. Further work is needed on potential bioindicator candidates. That's something that policymakers really would like to see. However, such an indicator needs to be robust and sensitive, but also very sensitive to ocean acidification specifically. And in addition, such an indicator needs to have a wide biogeographical range to be applicable or usable in an OSPAR context. And finally, then for policy, we've had recommendations to do whatever measure you can to reduce CO2 emissions, of course, and measures that remove CO2 from the atmosphere or the oceans. But of course, especially with the latter, we need to consider potential ocean acidification and other environmental impacts of these measures, especially when we're looking at geoengineering type of measures. Other measures that are much needed are those that enhance the resilience by reducing other pressures like nutrient inputs, pollution, and habitat degradation and destruction, but also measures that enhance the resilience by increasing biodiversity and community structure. For example, installing marine protected areas or other effective conservation measures, or reducing the overexploitation of organisms. So with that, I've come to the end of my talk. Thank you very much.
Thank you very much, Jos. Sorry about that technical glitch, but I think we got everything there. That was really interesting. So we'll keep questions for the end. So we'll move on to our second speaker now, which is Karol Kaliński from the Institute of Oceanology of the Polish Academy of Sciences in Poland. So Karol Kaliński is the head of the marine biogeochemistry section at IOPAN. In Sopot, his research focuses primarily on the mechanisms and processes shaping the biogeochemical cycles of carbon and nutrients and dynamics in the Baltic Sea and shelf regions of the European Arctic. Karol has also acts as the vice chairman for the Baltic Earth Science Steering Group and is an expert on the NCLIME Working Group on the Helsinki Commission, HELCOM, whose work concerns issues related to climate change in the Baltic Sea region. In 2021, the NCLIME team prepared the Baltic Sea Climate Change Fact Sheet, and more recently, Karol's been one of the main authors on expert works, which has resulted in the Baltic Earth Assessment Reports, which describe the current and expected future changes in the Baltic Sea region induced by human activity and global change. And I'd like to invite Karol to talk to us about oceanification in the Baltic now. Thank you.
Thank you, Helen. Can you hear me?
Yes, all good. Looks good. Sounds good.
Very good. I hope you can see also my slides, or the first slide.
Yes, yep, that's all working.
Thank you again. So, hello everybody. My name is Karol Kaliński, and as already introduced by Helen, I will present the ocean acidification topic from the perspective of the Baltic Sea. It will not be such a advanced assessment as it was presented by Jos from OSPAR, because simply for the Baltic Sea we do not have such an assessment of the ocean acidification. However, it does not mean that, that there is nothing to tell about. Otherwise, we have quite a lot to tell, both from the scientific side, but also the recent developments from HELCOM, so Helsinki Commission, towards establishing the policy science dialogue on presenting this assessment on ocean acidification in the Baltic Sea. So simply we are a little bit in terms of assessment in the back behind OSPAR. Okay, so what we can say about the ocean acidification in the Baltic Sea. So before I move to the Baltic, one quick slide on ocean acidification as a global mechanism. This is probably well-known a figure presenting the so-called killing curve, where we have the CO2 increase over time based on the measurements at Mauna Loa Observatory on Hawaii. And some decades later, they started also to measure CO2 in water, PCO2 in water. This is that green line here, green plot. And what we can see that PCO2 in water simply follows this in the atmosphere. In terms of trend, and because CO2 is acidic, we do have this pH decrease in seawater, which is presented in blue. So, and this is the more or less the fundamental understanding of ocean acidification. The scale of this trend, well, the ocean acidification, as was already shown for North Atlantic, it is measurable and traceable. And the trend is of about 0.01 to 0.02 per decade. So, and with this brief intro, I would like to present you even longer time series which we have in the Baltic Sea in terms of pH measurements, starting from already 60s last century. And you can see here this time series for different basins in the Baltic Sea. And there is one clear fact that the ocean acidification in sense of the pH decrease over time is not detectable in the Baltic Sea so far. So the question is why it is so. And here comes a few explanations. However, it's not easy to explain this. Well, first of all, when we look at the seasonality of pH in the Baltic Sea, and this is that gray plot, it corresponds very well to PCO2 difference, and these are measurements from the open Baltic Sea. The Baltic Sea water in winter is oversaturated with CO2, and then when the spring bloom starts, we have the CO2 decrease with CO2 minimum, PCO2 minimum in April, May about, and corresponding to that first pH maximum. And then once again, situation we have similar in midsummer, where we have cyanobacteria bloom in the Baltic Sea, and corresponding to that PCO2 decrease in surface waters, and pH increase, another maximum of pH. And then we have a period of relaxation where the PCO2 goes up and becomes oversaturated again in late autumn. So just looking at the pH scale, if you can see, is the seasonal variability, what we have in the Baltic Sea is more than 0.4 even. And just to compare this with this red dot, which you can see in the screen, in diameter, this red dot, this is a decadal pH change due to the ocean acidification in the open ocean, more or less. So you can see that the variability we have in the Baltic Sea is much higher than well, actually, ocean acidification mechanism itself. So this high variability is the one one reason why we have problems with detecting the ocean acidification in the Baltic Sea. But another thing is that not only CO2 plays the role here. So, and here once again, I would like to refer to the open ocean studies, and this is Bermuda Atlantic time series, where it's very nicely shown that in the open ocean, pH is a function of PCO2 in surface waters. And these are this lower panel where we can see that along with the PCO2 increase in surface water, we do have pH decrease over time. And everything happens in situation where we have pretty constant alkalinity in open ocean. And this is then the graph second from the top. Why I'm referring to alkalinity? Because it seems there is a main driver of well, ocean acidification related things in the Baltic Sea. And what actually total alkalinity is? Well, we can define it as an excess of bases over acids in water, which simply makes that the seawater is slightly basic. We have number of substances playing the role here, but it's not the most important. The important here, the phenomenon what we observe in the Baltic Sea is this. And well, I really like this slide and this diagram because it really nicely shows how complex the situation in the Baltic Sea is. And in the Baltic Sea, simply the same PCO2 may result in very different pH, and the reason is actually the variability in alkalinity. Where you see this horizontal line, so this is kind of equilibrium of seawater with atmospheric PCO2. It was already taken a few years ago, so still 400 microatmospheres. But let's assume for a while that that seawater is at equilibrium with the atmosphere. Then the pH, which is simply these isolines you can see in the screen, or also the colors, different colors you can see here, will be the result of total alkalinity. And total alkalinity, the range of total alkalinity in the Baltic Sea, is given by these two vertical lines. So from few hundred micromoles far north in the Gulf of Bothnia to more than 3,000 micromoles in the mouth, in the estuaries of the big continental rivers in the south and southeast. So, and just because of that, at the same level of PCO2, we will have very, very much different pH. And here is simply in the cross of this horizontal and vertical lines. These are the values, so from 7.7 to 8.3, just because of very different alkalinity. So the question is where this alkalinity difference comes from. The Baltic Sea is a brackish water body, so the salinity of about 7 only. And very much influenced by the very high freshwater input from the catchment area, which is more or less 4 times larger than the sea itself. And the thing is that when we look closer, we have very much different composition, geological composition of the catchment region in the north, in the Scandinavian peninsula, and in the south and southeast, I mean, this continental part of the catchment. And the thing is very well presented here in this graph. So simply freshwater components coming from different sources may have very different alkalinity end members. And just by looking at the salinity, you may see that this freshwater component is really the one playing the role. I mean, the composition of this brackish Baltic seawater, where we have the input of this North rivers, Scandinavian rivers, to the Gulf of Bothnia, which are very poor in alkalinity. The catchment there is made of granite mostly. And on the other hand, we do have a number of rivers where comes also these colors, Vistula, Gulf of Riga, and Oder River. These are continental regions, continental rivers entering the Baltic Sea from the south and southeast, which are a net source of alkalinity to the system because they drain limestone-rich part of the catchment. Also we do have the exchange of the Baltic Sea water with the North Sea and open sea conditions. So this is another line. And then this center of the Baltic Sea, which is of salinity of about 7, acts as a big mixing chamber where all these different influences meet and make the final alkalinity. So simply, depending on where you are in the Baltic Sea, you may have totally, the salinity may mean totally different alkalinity, and in the end also influence the pH and the ocean acidification. Spatial variability of alkalinity in the Baltic Sea is not the only phenomenon which influences the ocean acidification and these difficulties we do have with understanding ocean acidification in the Baltic Sea. Another thing is that alkalinity, we did detect long-term variability of alkalinity, or rather long-term positive trend in alkalinity. And it's presented in this upper panel where in surface water is of about few micromoles per year. Translating this everything into pH, assuming that there is ocean acidification going on. So we see that ocean acidification coming from the pressure of rising atmospheric CO2 is to a large extent mitigated by this positive trend in total alkalinity in the Baltic Sea. So the things are pretty complex here and not only driven by CO2. And now a few words about where we are in terms of meeting policy and science here in the Baltic. As said already, we are still in the very beginning phase of developing the assessment of ocean acidification. But ocean acidification have been already several times addressed in different actions, joint actions. So HELCOM, together with Baltic Earth, which is a platform, bottom-up driven platform of scientists working in the Baltic Sea from different disciplines, developed the so-called climate change fact sheet in the Baltic Sea. It was published and released in 2021, and there are a number of different parameters which have been identified and cross-linked with other and described in a very short and well, non-scientific way for policy, but also to general public. The situation about what is going on right now with these different parameters and what we may expect in the future. This among these parameters in gray, you may see in this circle carbonate chemistry, which includes also ocean acidification. And later on, just well, actually a few weeks ago, we have separated this even into the carbonate system on one side, but also having the ocean acidification totally separately, describing our understanding and well, state of knowledge where we are about this. It was not released yet and published, this separation, but will be soon. So this is one thing, this climate change fact sheets we do have in the Baltic Sea. Furthermore, we do have in HELCOM, well, there are altogether 59 indicators, different indicators, which HELCOM have as a basis to develop the assessment reports, their assessment reports. And within that, there is also acidification and pH. So, however, as said, the real assessment and the full assessment of ocean acidification is still in front of us. And this is because, I mean, what you could see, ocean acidification in terms of pH decrease is not detectable, at least yet, in the Baltic Sea. And it was not the biggest issue, the biggest environmental problem we do have in the Baltic, which is, I mean, on the top probably is eutrophication still. But yes, both scientists and also from the side of policy, I mean, HELCOM side, we are working on that. And in the end, 3 messages to take home. So ocean acidification in the sense of pH decrease is not detectable in the Baltic Sea so far. And the CO2 variability is not enough to understand pH dynamics in the Baltic Sea. But we need to understand the full acid-base balance. It has to be taken into account, which is pretty complex in the Baltic Sea. And in the end, ocean acidification in the Baltic is on the agenda of HELCOM, which is this policy side, but also Baltic Earth scientific side, and recently also a number of scientific projects. And probably we will end up soon in more coherent assessment, which well, we believe will be the basis for actions, and also reflecting this in the monitoring program, which is led by HELCOM in the Baltic Sea. And that would be all I would like to present you and show you. Thank you very much.
Thank you very much, Carol. It's really great to see the work that's being done there and understand some of the dynamics and complexity of the region. So as we said, questions we'll take at the end. So if I ask you to stop sharing screen, and we'll move on to our 3rd presentation, which is actually going to be a joint presentation between Inke Dressler and Annika Frosch. So Inken has successfully completed the joint Nordic Masters program in environmental law, making her a specialist in European law from Maastricht University and environmental law from Uppsala University, University of Eastern Finland, and the Arctic University of Norway. Inken is currently working as a consultant for the International Alliance to Combat Ocean Acidification. As part of this role, she is advising on topics related to the incorporation of ocean acidification information and response into the legal and regulatory frameworks of the European Union. The particular focus here is on the EU directives and regional seas conventions, and simultaneously Inken is commencing a 2nd bachelor in biology at the University of Hamburg to deepen her knowledge of the natural sciences. So lots going on there for Inken. And Annika Frosch is finishing her PhD at the European University Institute, where she is funded by the German Academic Exchange Service. Her research focuses on the governance of oceanification and specifically on finding government solutions which can deal with the scientific reality of this complex problem. And since January this year, she has also officially been advising the OA Alliance on topics related to the incorporation of acidification information across EU directives and conventions. And so these 2 lovely ladies will be talking to us about exploring marine management and policy response to ocean acidification. Thank you.
Well, Helen, thank you for the introduction. With our presentation, my colleague Annika Frosch and I would like to provide an introduction into the EU legal and policy framework that can be utilized to incorporate OA information. With that, we would like to give you a quick overview of our presentation. We are going to start with what our project is about and why we decided on a European Union focus. We will then share some insights from our side event at the European Maritime Day in Brest, France, which happened earlier this year, and which was our first opportunity to share some preliminary findings from our project. We will then present some of the materials that we presented at the European Maritime Day before we move on to our current focus of our project, namely the Marine Strategy Framework Directive. And we will finish with a future outlook into what is to come. All right, so the project we are working on, we got the inspiration from the Galdi's paper, which he and his colleagues published in 2020, which is called the Assessing Frameworks for Implementing Ocean Acidification, European Policies and Legislation Targeting Ocean Acidification in European Waters. We then got further momentum from the already mentioned OSPAR Quality Status Report in 2030, which also has a chapter on ocean acidification. The reason why we decided to focus on the EU for this project is, for one, that the EU has a unique and shared policy and legal structure which it shares with its member states. And moreover, within the EU, there exists a great accumulation of extensive OA-related research, especially also through the GO-ON networks, which otherwise can only be found in the US. Following from this extensive OA research, done within the EU, we became interested in the question of how this knowledge has been translated into legal and regulatory frameworks, namely in our case, directives, which are so-called specific EU law instruments and regional seas conventions. We then shared, as already mentioned before, our findings at the European Maritime Day in Brest.
Yeah, so the European Maritime Day in Brest took place early this year in May, and this was a good opportunity for us to share our first results with some policymakers and to get an understanding of what they find important and what they find interesting in our findings and what else they would like to see. And the European Maritime Day is an event where Europeans' maritime community is networking and discussing and outline a joint action on maritime affairs and sustainable blue economy. So it is basically the perfect event for us to get in touch with policymakers. So we decided to host or co-host an event called Exploring Marine Management and Policy Response to Ocean Acidification. And we co-hosted it together with the OSPAR Commission, the GOA-ON Northeast Atlantic Hub, and the OMET Hub. And as I said already, it brought together policy and decision makers across Europe. We had a few points that we discussed during European Maritime Day, but the third point here on this slide is the most important one for this presentation and is the relevant EU and national ocean and marine policy frameworks to address and minimize ocean and coastal acidification. As Inken already said earlier, we chose some materials that we wanted to present to some of the policymakers to gain feedback. And these are particularly some of the conventions that we looked into and the bodies that have relevant responsibilities within ocean acidification. So here we have the OSPAR Convention and the OSPAR Commission. We have Helsinki Convention, HELCOM, Barcelona and Bucharest Convention, as well as the Arctic Council. And what we have been trying to do in our research was that we really looked into these different bodies and conventions and tried to understand what are they already doing and what of that is relevant for ocean acidification, and are they maybe already doing something in this regard. So what you can see here on the slide is just a template that we then later filled out, and you can see we looked into their existing efforts and tried to understand the relevance for ocean acidification. So in particular, we looked into monitoring, we looked into reporting, reduction of CO2, reduction of other stresses, such as also land-based pollution, and in building ecosystem resilience. And based on that, we could see what member states found useful and base our further research also on this type of structure. And we didn't just do this with the conventions, as Inken already mentioned, we also looked into the directives that Inken will talk about next.
Yes, so the directives we focused on the EU level. So we were talking and looking into the Marine Strategy Framework Directive, the Marine Spatial Planning Directive, the Water Framework Directive, the Nitrates Directive, the Habitats Directive, and the Birds Directive. And similar to what we've done with the bodies and international conventions, we then came up with a table that on the left side, you can see the directives, and on the upper part of the table, you see the different mechanisms for which OA information could or can be incorporated into these directives. Here we have, for example, OA monitoring again, OA reporting, OA research, mitigation and remediation, adaptation and resilience building. And here again, schematic, only just the boxes in blue show where some of the mechanisms are incorporated in the directives. So from this rather high-level overview that we presented at the European Maritime Day, we then decided to focus our efforts specifically at the Marine Strategy Framework Directive, as the discussions at the side event, as well as further discussions with the EU Commission afterwards, showed us that the Marine Strategy Framework Directive is indeed one of the most impactful legal instruments to address and incorporate OA information. Additionally, the MSFD is also currently in the process of being revised, which gives us an additional opening for OA recommendations. So what is the Marine Strategy Framework Directive? Well, it is a European Union legislation which aims to protect the marine environment, especially the marine ecosystem and biodiversity. It has the overall goal of achieving good environmental status within the EU marine waters. And to achieve this good environmental status, the EU waters must be dynamic, ecologically diverse, clean, healthy, productive, and the marine environment must be able to sustain sustainable use and activities by humans. Besides this general and overall goal that is laid down in the MSFD also lays down a couple of steps that the member states have to follow and achieve in order to, in the end, achieve this overall goal of good environmental status. First, the member states had to come up with initial assessments to determine the characteristics which were important for good environmental status in their sub-regions. Here it is important to understand that the marine waters of the EU were further subdivided into specific sub-regions, depending and thereby giving an overview and helping with the regulation of the marine waters in general. Then the second step was to come up with monitoring, assessing, and reporting of the environmental status of these waters, which had to then be provided to the EU institutions. And then there's also step 3 and 4, which is the establishment of environmental targets and other indicators which are supposed to help with achieving good environmental status, as well as the establishment of programs of measures. And here again, as a side note, just that there's the overall revision of the MSFD pending until 2030.
Yes, because of this revision, we really started into looking into the core of the MSFD and see where we can basically target and implement ocean acidification. So one of the core elements of the MSFD are the MSFD's descriptors. There are 11 of them, and they describe or they can be used to determine the characteristics of good environmental status in a marine region or sub-region. And as I said, there are 11 of them, and many of them are also useful for ocean acidification. So on this slide, you can see the ones that are relevant, for example, descriptor 5 and descriptor 7. While 5 is dealing with eutrophication, descriptor 7 is talking about hydrographical conditions, and ocean acidification would fit nicely within these two descriptors, but has not really been mentioned thus far. In addition, there are 3 descriptors that deal with the importance of the ecosystem. Also there, of course, ocean acidification could be considered, which are descriptors 1, 4, and 6. We have selected these descriptors because we want to prevent opening up the entire descriptor discussion so we don't have backlashing. But we want to integrate OA information nevertheless into the descriptors that are already there instead of opening a new one, just focusing on ocean acidification. As I said, so far, it has not been mentioned in the NSFD. The only time a reference can be found is in Annex 3, Table 1, which mentions pH as one of the characteristics that must be taken into account when it comes to states making initial assessments that Inken already talked about in Article 8, or when determining good environmental status in Article 9, as well as monitoring programs in Article 11. So based off all of this information, we have, as the Alliance, made some plans for what our future work should look like. And most importantly, we will continue to work with our buddies and partners, such as HELCOM, Barcelona Convention, OA Mediterranean Hub, and so on. And we want to really communicate our information that we have collected to those partners and hopefully receive feedback from them to work on our findings. As we then also want to make specific recommendations to the EU member states in 2024. The MSFD envisions that member states make or report on their status of different the different obligations they have under MSFD. So this entails, for example, the monitoring programs that the member states are doing or the program of measures, and they will report and give a status of those back. And we hope that ocean acidification information can be integrated within these different deadlines. And as Inkin already said, of course, by 2030, the revision of the MSFD is pending. And we would like to also give further information to the revision, and that is possible in 2024 through the public consultation, where we can feed our input and have it considered for the revision of the MSFD. And this is our presentation for today, and thank you for having us.
That's great. Thank you very much, Inkin and Annika. That's really interesting to see the work that you've been conducting there. Again, like I said, questions and answers either in the box or save for the end, and we'll move on to our final speaker. So I'd like to invite Maribel García-Ibáñez. She is a postdoc at the Institut de Ciències del Mar in Spain. She's a biogeochemical oceanographer interested in the link between chemical and physical oceanographic processes and their implications in the marine environment. She's a member of the Scientific Steering Committee of the International Ocean Carbon Coordination Project under the theme Ocean Interior Observations from Ships and Autonomous Vehicles, where she helps to coordinate the discussion on the new design of a new, more resilient production model of reference materials for the seawater carbonate system. Maribel, over to you to talk to us about progress towards a new system, reference system. Thank you.
Thank you, Helen. Hopefully you can see my screen and can hear me. Okay.
Yes. Hear you,
yes,
see you.
Perfect. So thank you very much, Helen, for your introduction, and thank you all for joining us today. As Helen said, I am Maribel García-Ibáñez, and with this presentation, I will update you on the progress towards an integrated carbonate system reference material production and certification system in Europe. So, as most of you know, the global networks established to quantify and understand the oceanic carbon uptake and monitor ocean acidification rely on the availability of reference materials to achieve comparable measurements. But the supply of these reference materials for the seawater carbonate system relies on one single laboratory managed by Dr. Andrew Dixon at the Scripps Institution of Oceanography in the US. And the COVID pandemic highlighted the fragility of the carbon production system of the seawater reference materials for the carbonate system, with a dramatic reduction in the supply of reference materials during the pandemic that forced many groups to produce in-house or working reference materials, which is a challenging task since there are no standard protocols for their production yet, thus resulting in non-uniform production and compliance measures and uncertainty. So what can we do after the COVID-19 shortage of reference materials? We can continue as we were, with one laboratory supplying reference materials for the entire community, which we already know is a fragile system. Or we can create a more resilient system that doesn't rely on one single producer. This can be achieved in two ways. Either each country produces their own reference materials without global coordination, or we can create a global coordinated new model consisting of multiple production and certification hubs of reference materials. And this third option is what was discussed during the online meeting organized by IOCCP, the International Ocean Carbon Coordination Project, in spring 2022 to create a more resilient system. This global network of production and certification of reference materials could involve the establishment of spaces capable of bottling and distributing seawater in geographically strategic locations, with one hub remaining in the United States, and the creation of at least 2 additional hubs, one in Europe and one in the Asia-Pacific region. The proposed new model would split production from certification. Regional hubs could send their samples to a highly qualified laboratory, such as a National Meteorology Institute, where they will perform the certification. The integration of the new model into the global meteorology landscape will help to produce reference materials that are comparable and meteorologically traceable to the international system of units. Therefore, this proposed new model would require unprecedented involvement of national meteorology institutes on a global level. The meteorology community is aware of the shortage of reference materials, and one of the recommendations on standards and standardization work to support both climate change observations and greenhouse gas flux measurements that came out of the BIPM WMO workshop on Meteorology for Climate Action 2022 highlights the need for reference materials for the seawater carbonate system that are comparable and meteorologically traceable to the international system of units. BIPM and WMO are already working on turning those recommendations into actions. Therefore, there is a willingness from national meteorology institutes to help with the reference materials new model. There is some progress toward the establishment of certification capacities in the US Meteorology Institute NIST, with an estimated date for first certifications during 2026-2027. I refer the audience to check the GOA-ON week webinar we gave in May 2023, which is available via the GOA-ON YouTube channel with direct link in the QR code. In the case of the Euro-African Hub, its creation presents some challenges, such as the identification of institutions that lead the effort, the difficulty of coordinating different countries with different capacities, and the need to find subsidizers if we want to replicate the US model, which is partly subsidized. But it also comes with some advantages, such as the existence of the European Meteorology Network for Climate and Ocean Observations, which was established in 2014 by EURAMET, the European Association of National Meteorology Institutes, to improve the quality of essential ocean variables by increasing linkages to the international system of units and improving measurement accuracy, among other objectives. Also, the precedence of creating linkages between the European oceanography institutions and national meteorology institutes through the European projects MINCE and SAFTICE. The fact that some European national meteorology institutes are already researching measurement services related to the seawater carbonate system measurements, and the fact that GPI Ocean's ocean carbon capacities is willing to act as a focal point to catalyze activity and resources for coordinating the hub creation. For those unfamiliar with GPI Ocean's ocean carbon capacities, briefly, this joint action was launched in 2020 to investigate the ocean's capacity to absorb carbon from the atmosphere. In a first phase, that is finishing now, the joint action has consolidated and structured the expert group and explored pathways for actions and collaborations. One of those actions relates to reference materials for the seawater carbonate system to be addressed now as part of, a second phase of ocean carbon capacities in the form of a knowledge hub. Knowledge hubs are temporary networks of experts from GPI Ocean's member countries with the goal of delivering specific outcomes or products and draws on existing national programs and ongoing European projects to address knowledge gaps. The Knowledge Hub can leverage financial resources by matching cash and in-kind contributions. The GPI Ocean's Ocean Carbon Capacities Knowledge Hub aims to act as a focal point for establishing a European capacity to produce the carbonate system reference materials required for ocean measurements and anthropogenic carbon and coastal ocean acidification. This will involve contacting representatives of key international networks, funding agencies, and meteorological laboratories to develop a plan that meets the needs of the scientific community, can be implemented, and has the buy-in of key funding agencies. Preliminary work undertaken for this action suggests that laboratories are willing to enter this dialogue and a mature scientific implementation plan exists. But for the creation and maintenance of the proposed integrated carbonate system reference material production and certification system, we need to coordinate and foster the initiatives related to the development of such production and certification hubs, both in Europe and the Asia-Pacific region, implicating all the actors involved: scientists, national meteorology institutes, companies, funders, and end users. And here is where IOCCP and GPI Oceans come into play, helping coordinating those discussions and funders in the case of Europe. but we need you. If you consider yourself one of those actors or know someone who may be, please contact us via the IOCCP email. And this is all from my side. Thank you very much.
Thank you very much, Maribel. Really great to hear the suggested proposed model for moving forward with that. It's been a discussion that's been on everyone's minds for a number of years now, so really great to hear that progress. So on that note, I don't see any Q&As in the question box at the moment, but please do either put them in the question and answer box, or you can also raise your hand and ask a question directly, and I'd invite all the speakers maybe to turn their cameras back on for this last discussion session that we have available now. And if anyone has any questions, this is your opportunity to find out more from the speakers or hear anything else. I think, yeah, Thorsten.
Yeah, I couldn't, maybe because I'm in this speakers panel, I couldn't find how to type a question in the Q&A. So, but anyways, so question to Carol actually about the Baltic. So that was really interesting. I learned a lot of things. One being this high seasonality actually of in the carbonate system. Let's put it that way. And I wonder, has anyone looked into whether there is a special adaptation of the ecosystem to this variability? Probably hard to distinguish from everything else, but anyways.
Yeah, thanks, Thorsten, for this question. Well, indeed, there are some studies looking into that. The Baltic Sea ecosystem is quite different from open ocean because of low salinity, and because of this different structure of carbonate system. We, for instance, do not have planktonic organisms. I mean, this calcifying organisms like coccolithophores, for instance. They do not bloom in the Baltic. So the only organism which made their exoskeletons out of calcium carbonate are mussels, which we have some. And it seems that for them, for the moment, it's not a problem. But generally, the structure of the ecosystem is investigated. I mean, the resilience of it from the CO2 system, this pH variability, which we have even higher than what I presented. It was for the open sea, but we have even higher close to in shallow coastal areas close to river mouths, for instance. So it seems that the biodiversity in Baltic Sea is lower. I'm not biologist, but what I can tell about this is lower than we know for the open ocean. But it's more resilient to these harsh conditions. Kind of harsh conditions in terms of very high variability we do have in the Baltic. There are several studies running around the Baltic Sea looking in details for different species and different organisms. How do they react for this variability in pH and generally in CO2 system variability?
Great. I actually have a question. Jos, when we were doing the report, it became apparent that there was a fair amount of pH data, but not necessarily full carbonate chemistry. It made it difficult. What are your thoughts on how we can improve that monitoring capability? Do you think that's a funding requirement, or do you think it requires a bit of just knowledge exchange, commitments by countries? Have you got any thoughts on how we can improve that monitoring capability across our region?
good question. I think it requires some dedication by contracting parties to actually invest in this type of monitoring. I know that in the Netherlands we've started a good amount of Institut points where we measure all the aspects of the carbonate system on high frequency, but or monthly. That's fairly high, I would say. But it's also quite expensive, right? So I think we as a community also have some convincing to do to show what it is that the policymakers would get out of it, because I think that's often quite hard to explain. I often get the ocean is acidifying, so what? I mean, what can we do? So it's a bit fatalistic, but so we need to show that there's perspective and that through the monitoring we can improve the situation in one way or another. So it's a bit of a two-way operation, I think.
Yeah, absolutely. Dustin, I see your hand again. Please go ahead.
But I think the Q&A was first, so maybe I shouldn't monopolize this. So there's one in the Q&A.
I see it coming now. Yeah. Jessie, are you on the call? Would you like to say it out loud? Or I can read it out. It's from Jessie Turner, which is to Inken and Annika. Do you think the European Commission, particularly DG Environment, has been open to thinking about how to better integrate OA information reporting across the Marine Strategy Framework Directive? Who wants to pick up on that one?
Well, thank you, Jessie, for the question. I have to say, during our calls that we had with the Commission so far, they have been very open to discussing and also trying to understand themselves how to incorporate OA information into especially the MSFD descriptors. So yes, I would say they have been very open to discussing. I hope I answered the question right. Oh, well, that's what I mean, not well, right? Well.
Yeah, it's good. It's good to hear, and I think it's important that we have these discussions directly with them if we can. For that, Annika, did you want to add anything?
I would say one of the challenges was definitely to see, like, scientifically understanding ocean acidification and how does it fit into what they have foreseen within the descriptors, like where does it actually fit and where does it not fit that well. But they have been really good at listening and discussing our thoughts on that. So I would agree with what Inken said for sure. And I think with the revision due in 2030 and so many deadlines coming up for the member states, is definitely an ongoing discussion that they're really happy to have.
Thank you. Dustin, I'll pass back to you.
Yeah, and I actually changed now questions on my question is directly to this now. Do you actually really think that what is it then, ocean acidification or pH or so is a good indicator of the good environmental status of a marine system? Or what is it that you would measure? Just pH? Actually, from Carol's presentation, I took away a little bit that it's maybe moderately meaningful for the health of an ecosystem.
If I may, so I think this is a very difficult question. What exactly we're gonna measure? I think that's maybe more a question to all the scientists, obviously we're more from a policy perspective. But since the descriptor are already looking at things that are extremely related to ocean acidification, such as eutrophication or other conditions of the ocean environment, one will question why we're not looking at, for example, pH as well. If pH is now the best measurement or form of measurement, I think I would like to ask that question myself, I guess, to the scientists, if someone has more insights on that. But I do believe if we're already working so much on different other aspects of ocean health, let's say, why would we not also include ocean acidification if we can?
Jos, you have your hand. Jump in.
Yeah, I just also have a comment in relation to this. because I think it's a good question. But the alternative is, so that's I guess part of the conversation that we still need to have, is that in one thing you could, let's say, determine good environmental status in terms of pH or other elements of the carbonate system. But the other thing you could do is define good environmental status of other components of the ecosystem, knowing that pH is going to drop or other changes in the carbonate system are going to occur. So then you take ocean acidification into account in the other relevant aspects, and then it might also have a place in the MSFD, for example.
I think we had Jessie quickly had her hand up first, I think, if you want to jump in.
Yeah, can you guys hear me okay?
Yeah, great.
Cool. No, I was just gonna, great ongoing discussion. And I think that's why through the Alliance, we're excited to keep working with OSPAR, with the GO-ON hub, as well as some of the other regional seas conventions across Europe, and really having this conversation to say what is the most useful role for OA information across the descriptors and across MSFD. I think in some ways it's also just an opportunity to think about more intentional coordination on biological research. And that's one thing that we've been thinking about, as Jos's report was revealing some of the needs for next steps and really thinking about targeted species response. How do we make sure that the descriptors are helping us anchor that work, or make sure that that work is being taken up and understood by policymakers in a meaningful way? So there's some of that cross-pollination as well that I'm looking forward to working with all these bodies together in these conversations with the Commission moving forward.
Yeah, that's a good point, I think, and we have to remember that these impacts are on the biology, so the chemistry is changing, and that's the indicator of that chemical change, much like the nutrient status or something. The nutrient eutrophication status takes into account nutrient, but also phytoplankton and chlorophyll aspects as well. So, Carol, can I invite you to comment?
Yes, thanks a lot. Just also a comment for that discussion. I mean, ocean acidification in general has already in its name has some message, ocean acidification. So just by this, what I showed you, I mean, the examples from the Baltic Sea, one can see that the mechanism and the problem is very complex, or might be very complex locally. So I would really encourage in the discussion generally, I mean, between policymakers and scientists and so on, that sometimes it's simply impossible to simplify the messages and texts and so on. And well, the Baltic Sea example, I think is very good here when we say about ocean acidification, but we have the very complex chemistry behind and actually no detection of pH negative trend over time. So as said, we are trying to build the discussion in the Baltic Sea community, including Helicom and this policy side, but also experts from scientific side. To have this joint understanding and to think how to proceed in the future. But this Baltic Sea example, this might be only an example, right? For other regions and places where also this complex chemistry might play the role. And this will refer especially to the coastal regions. So it would be wonderful if ocean acidification would be developed more and more, not as a joint effort for open ocean and coastal seas, but my understanding and feeling is that coastal problems, marginal seas, ocean acidification has or may have different meaning and understanding in the end than in the open ocean. So I would really love to see this coastal things addressed separately a little bit.
I think that's a really, really good point, actually, and it's come up a couple of times. Actually, I was speaking to some people in the Latin American hub not that long ago, and they were having a similar discussion about the fact that we need to maybe distinguish a bit better between coastal acidification and the multitude of complex processes that go on in those regions compared to the open ocean system, which is really driven a lot more by the emissions and CO2. So I think that's a very valid point. And yeah, Thorsten, do you want to comment?
Yeah, exactly. Kind of so extending that thought and asking the question to Maribel, then is it enough to have, or is it optimal, let's say, to a good design to have a Euro-African hub, or wouldn't it be more helpful to have different reference materials for the Baltic Sea, maybe for the North Sea, maybe for the Mediterranean, and for the open Atlantic?
Yeah, thanks, Thorsten, for the question. Yeah, Carl, you want to answer or?
No, sorry. I didn't see that I'm unmuted. Sorry.
Oh, sorry. No worries. Yeah, so this was already discussed in the meeting we had last year. We are aware that the reference materials that we have nowadays are maybe not suitable for all the environments that we are measuring the seawater carbonate system. And I think the structure that we are proposing with having different hubs is just now to kind of build the capabilities, but with the idea that maybe having different locations where they are, the reference materials are produced will allow us to have reference materials with different compositions, such as Mediterranean seawater. In the case of the Baltic, as Carl already was explaining, it is a complex area with different loads of organic matter that will complicate the certification bit of the reference materials. Will also create unstable materials since they are based on natural seawater. So having a composition like the Baltic seawater will maybe problematic for reference materials, but this can be something that can be discussed when we already have a bit more established the hub structure, and we can see with the Meteorology Institute if they see no problems in certifying materials with high loads of organic matter or low salinities and things like that.
Inken, you have your hand raised.
Yes, thank you. I just also wanted to add to the previous discussion on the Marine Strategy Framework Directive descriptors that one of the reasons also why we're not pushing for one descriptor on ocean acidification or pH is also this discussion that we just had, that it's so complex and it has so many different aspects playing into it. So that's why we also think that it is important to incorporate OA information into different descriptors, just also to take into account all these different aspects and viewpoints that we just discussed.
I think that's really important, and I think this is a great conversation to have when we're thinking about what are the best ways we can set up our monitoring programs. So not only communicating what it is the policymakers need or want from us, and what are those OA indicators that we provide to them, but actually how do we then go about setting up our next big monitoring programs and things around this, our coasts and regional seas. Thorsten.
I can add one more, maybe a little provocative. I think Jos, you said that the question comes often, so, well, ocean acidification, so what can we do about it? And well, I think you probably know better than me that one of the carbon dioxide removal ideas is actually ocean alkalinization. So kind of throwing dust into the ocean to provoke some fast rock weathering to sequester CO2. So isn't that then a great way of solving two problems? So sequestering CO2 from the atmosphere and stopping or mitigating acidification.
Yeah, in theory, that might be a great idea. I do think that we as humans have a tendency to solve problems by creating new problems. And especially with these kind of interventions in the environment, what we see, this is at a very high level, but what we see is that organisms respond strongly to quick and drastic changes in, let's say, the carbonate chemistry of the water, which goes from algae and zooplankton all the way to bigger organisms. And if you start doing these kinds of things, you're going to impact the environment of organisms quite strongly, because you're drawing CO2 from the water, but you're also drawing CO2 into the water. So the whole dynamics of the system is potentially quite impacted. So you might have an impact on the more biological side there. So you might solve a chemical problem, but I'm not so sure whether that's. I would be very cautious with just doing that. I would look very carefully into that.
Yeah, I think, yeah. Go on, Justin.
I guess caution is good. At the same time, it's not that we have a pristine system and would start to impact it. It's already heavily impacted. We are beyond the stage where we can do nothing. But anyways, I mean, that's really a big discussion. Sorry.
A big discussion, but an important one, but perhaps not for the last minute of this session today. But I think it's another factor that we need to consider, especially when we're thinking about monitoring. Again, it kind of comes into one of these aspects. Where do we do these sort of activities? Where's the biology most going to be responsive? Where's it going to be least responsive? And where do we have our monitoring sites that allow us to be able to monitor the natural system and the changes that we make to that natural system in order to be actually see changes and see benefits or not, if in certain instances. So I think that's all things that we need to consider. But I think we're now just about out of time. So I'm going to hand back to our Katarina, our hosts, to close this meeting. Thank you.
Thank you very much, everybody. That was a very interesting session, and I'm very happy to see the conversation happening between the panelists. That was very interesting to see the different points of view. So again, I would like to thank you all for participating. I'd like to thank the organizers, the presenters today. I'd like to thank you all for taking the time and to be part of Ocean Acidification Week. We'd also like to thank the audience for joining us for OA Week 2023. And please don't forget to consult the website. We still have a day and a half to go in OA Week and plenty more sessions where these came from. If you'd like to stay up to date with GOA-ON and the community, then please consider signing up as a member of GOA-ON on our website, goaon.org. And to discover more about ocean acidification research for sustainability, the Ocean Acidification UN Ocean Decade Program, please use this QR code or join us on the website. With that, I'd like to thank you all again, and we hope to see you next time. Goodbye.